Okay, so we just talked about how we're in our last part of this semester. We're starting part 2 of Unit 2. So, big picture idea, we're going to finish up step functions today. We're going to look at piecewise functions for several days. And then next Friday we have a quiz. The next week we do composition with functions. And then our assessment is a turkey activity on that Friday. It's not a quiz, but it is an assessment grade activity. Then we have Thanksgiving break. We come back, we do inverses of functions, which I really like. We're finally doing some good math that you could see on higher level thinking problems. And then we have a little bit of 3D interesting things. Hopefully we can do some learning tasks with that. I've got some video clips from different movies that lead us into thinking about mathematics, and we can talk about the logistics of is it possible or is it not possible? Does the math behind it work or is it just fake? All right, so that's what's coming up. And today we're going to start by trying to graphically display a scenario that ends up being a step function. But then we're going to talk about, is it the greatest integer x, like we talked about yesterday? Is it a rounding down function? Is it a rounding up function? Or is it just a discrete graph that has lots of jumps in it? What is it? Okay, so the first thing we're going to look at is sales tax. It says we're selling candy bars. The taxable amounts imposed up to $1 shown below. So amounts from 1 cent to 20 cents, or a penny, 20 to 40, 2 cents, greater than 40 up to 60, 3 cents, greater than 60 up to 80, 4 cents, and greater than 80 up to $1, 5 cents. Is this accurate for where we live? No. What's our sales tax rate? 6. What's Coweta's? 7. What's Fulton's?
5.
No, it's
8.5.
I think it's 8. I looked yesterday and they have an extra penny sales tax. Okay. Why are they not the same?
Because it's based off.
It's based on
Population.
how much it takes to buy and build.
Who has the most money?
Your county gets to pick. And sometimes we have extra things that go in our sales tax. Like sometimes we have an extra penny and that money goes to technology in schools. Sometimes we have different things we can add on to our sales tax. What other taxes do we have?
Income tax.
We have income tax. Now, is that the same across the board for anybody in Georgia?
No. Doesn't it
Yes.
depend on your...
That's state income tax. So income tax is the same across the board.
Well, what about the yearly tax?
Okay? Are you talking about federal tax?
Yeah.
Okay, your tax rate in both state and federal depends on your income.
Doesn't it, and also like the amount of people in your family?
The number of deductions and things like that, yes. That depends on the members of your family. Are there any other taxes?
Income tax.
Okay, we talked about income, that's our state tax. Who owns a car?
I don't own it.
Oh, you're right, you don't own it.
Yeah.
Your parents, maybe some of your parents are very generous
I bought mine.
and allow you to drive a car. They don't allow you to drive?
I had a
Smart
They let
parents.
me drive sometimes theirs, but
Ooh.
they're not home a lot, so
Okay.
I take my roller skates.
Alright, so we do have a tax that we pay with our cars every year. It's for our tags. Okay, so there's a tax built into our tags. There's another tax.
living, like where you live.
Where you live, your property tax.
Yeah.
Now, is that the same across the board?
Oh.
No. Property tax changes depending on where you live. Like,
Under a bridge.
I currently live out in the middle of nowhere in Coweta and have a little bit of land and a nice size, bigger house than I need.
How long does it take you to get
And if we picked up my property in my house and plopped it in Fayette County, my taxes would double.
Really?
Yes.
Wait, how much money do you
Is that
have?
why you don't
Like,
pay them?
like 2 weeks.
Oh, okay.
Yeah. No, I don't have a ton of them. I can barely take care of my 2.
How long does it take you to get to school?
Huh?
How long does it take you to get to school in the morning?
Only about 20 minutes.
chickens?
Do I have chickens? No.
Do you have a baby goat?
Yeah, I have 2 dogs and 2 cats. Alright. So we're just looking at one type of tax, and taxes vary depending on what kind of tax we're talking about. But here we're talking about sales tax. And in this given situation, they have divided it up to where we can graph it as a step function, not a linear function. This would not be continuous. So I want you to take a second and see if you can create a graph that aligns with this scenario.
So each scenario?
Each scenario.
Is Lily in the spread? Because I'm not totally sure.
I was thinking that.
Cheating.
Cheating.
You gotta learn yourself.
Alright, thanks, Dad.
I'm not sure.
Alright, well,
Matt, screw these note cards.
mine.
I guess.
Definitely gave that. Put it on your desk, you hot dog. I owe you $6. I think I did it right. Did you have to switch to open and close?
Yeah.
I don't want to keep going, but I think I got the right
One time.
That's what I missed.
Matt, line projects. We did.
I was asking, like, if you had to write I don't want to keep going.
Was it hard?
Because you don't pay attention.
Is that close? That should be close. That should be close. It's not like that. It's not anywhere.
Like when you ever connect dumbbells.
Wait, so Miss Willoughby.
You do. Yeah, and this first one switches actually.
Wait, so the first one.
Alright guys, now that you've had a few minutes to think about it, this first dot is going to make total sense when we talk about it. If we buy nothing, do we pay any tax?
No.
No. So there's like a point right here at 0, 0, right? But if we spend any money, aren't we going to pay tax? Yes. And up to 20 cents, we pay a penny. So it's an open circle right here at 0, because if we bought nothing, we'd owe no tax. But everything in between, 1 cent, 2 cents, 3 cents, 4 cents, for all of those, we pay a penny in tax. Okay? It's open circle here to closed circle there. And the reason it's closed at 20 is because if we spend 20 cents, we pay a penny in tax.
So that would be like basically equal
I'm not
to.
even meaning to. I'm just putting my feet down.
Miss Willoughby, so that would be like the equal to.
I think we're on a page
Alright,
right now.
so our next step, at 20 cents, anything over 20 takes us up to 2 cents. From 20 to 40. Now at 40, anything over 40 is going to pop us up to 3 cents. Over to 60. And then 4 cents from 60 to 80, or from over 60 to 80. And then finally, 5 cents is what we pay for over 80 to $1. Does that make sense? Okay, so let's take a look at our questions, which I've gotten rid of, so let me go back and snag those. questions. A candy bar costs 55 cents. What is the total cost with tax? So if we come over here to 55, now right there, what would the tax rate be? 3 cents. So 55 cents plus 3 cents would give me a total cost of 58 cents for my candy bar. Now, if any of you have been to the convenience store in the last decade, you'll know that 55 cents for a candy bar is a great price.
Correct.
Candy's crazy expensive.
Normally like 129.
I know. Yes, ma'am.
Why
You
are
go
the
to
prices of
Dollar
things
General.
always end in 99?
That is a good question. I wonder if there's a mathematical reason for that. I think that's more of a psychological reason because it makes you think it's cheaper.
But it's not.
But it's not. Yeah. And then the other thing that gets me is the gasoline. It's like 205.9 a gallon. That always cracks me up too. All right. So here we go. Your aunt purchases 3 bars at 55 cents a piece. What is the total cost? All right. Now,
Each piece.
could we just say 3 times that total cost that we figured out?
Equal.
Or do we have to do 3 times the 55 and then add the tax to that? I want you guys to determine what the totals would be both ways. And let's see. Let's compare. All right, go.
You're good. I think it would be the same.
Put a buck on it, but it's the one on the left.
Yeah, it's the same.
$1.65. What?
God, no, I haven't added. Chill. I haven't added my 9.
Oh, yeah, but I bet. I don't like it.
Wait, that's gross.
I know, I didn't
And the taxes on the
Yeah, I don't think it's enough.
Okay. So, real quick, do you guys always jump for your calculator? Or do you do things like this in your head? Do you split this 58 into 50 and 8?
Yeah.
And then go, this is $1.50 plus 24 cents is $1.74. Okay. So use those properties you started learning in elementary school to your benefit. Alright? We don't always have to grab for our calculator, even though some of us are just kind of in the habit of doing that. Alright, so this would be $1.65. So since it's $1.65, $1 would be 5 cents. And then 65 would fall right here, so that'd be another 4 cents. So 165 plus 9 is 174. Now those of you that actually have jobs and you work, you know that we pay tax on the total, right? We wouldn't pay tax on the individual. Sometimes it makes a difference. Not always, but sometimes it can. Okay.
Which one do you want us to usually use?
This one.
So,
This is the one we should use.
okay, that's what I-
Total plus tax. Yeah. And is all tax the same?
No.
No. When is tax different?
Depends on like what's being taxed.
It depends on what you're purchasing. Is food taxed at the same rate as other things?
No.
No. Did y'all know that? Okay. Those of you that have jobs probably do, because you see it.
I'll have a job, but I.
Food is taxed at a different rate. Yeah, but not all food products.
Let's see.
Some food products are excluded from the discount. Okay. All right. So someone's purchasing 4 candy bars at 55 cents a piece. They give you $2.25. Is that enough?
No.
No. How much more do they need?
Like 7 cents.
7 cents. They're 7 cents shy. So 4 times the 55 cents is $2.20. So that would be 11 cents tax. So they would owe you $2.31, and they tried to give you $2.25.
So 6 cents.
6 cents.
See, I got 232, so I had something else.
It was like
I don't know what I did wrong.
So hopefully if it's a little kid and they're cute, hopefully you have one of those little penny things right there at the register.
What did he
And
put?
you just take 6 of them.
What did he put 1, 2?
Yeah.
0.12. Alright, so the $2 would be 10 cents and 20 cents would be another penny. Right?
How did he put 1, 2?
No.
I don't know what I did.
Okay.
Oh, I do know what I did wrong.
Alright. So, let's take a look at our second example. This one's on postage. And these were first class mailing rates. Say we have weight not over in ounces, 1 to 13. And then we have the corresponding prices for the weight of the object that we're mailing. Now, when we graph, and we have just a scenario, we have a situation, the first thing we have to determine is what's our independent variable and what's our dependent variable. Because when we graph, we like to place the independent variable on the horizontal axis and the dependent variable on the vertical axis, on the y-axis. So in this case, which one is independent and which one is dependent?
Independent.
Independent is the weight and dependent is the price. Now, generally the independent variable is on the left, but not always. So you do have to read. And the way I always figure it out is I like to be able to say, does this depend on that? It's easier for me to figure out the dependent variable, and then by process of elimination, I've nailed the independent. So the price of what I mail depends on how much it weighs. So I know price is dependent. Okay, so now we need to set up our scales. If we count across the bottom, we have our independent variable, so it's weight in ounces. So we would definitely label our axis as weight, and it's nice to give a unit because then individually we don't have to list the unit every time. Okay, so weight in ounces. And I think we have enough here to where our scale could just be 1. Yep, it works. So our graph is large enough to where our scale could just be 1 on our horizontal axis. Okay, so our vertical axis, that's where we'll place our dependent variable, which in this case is price. And it's price in dollars. And now we have to determine an appropriate scale for this axis. We need to at least get up to 3.26.
0.10. 0.5. 0.25.
Well, what's the lowest?
Every 2
Yeah,
to 0.5. Every 2
So 0.25.
0.5.
0.2.
0.25.
Okay, so you want to count by 0.25?
I want to go by 0.5. But
Okay, 0.5, we'd be at 3 right here. And we haven't really used up our axis nicely. We've scrunched all of our data really close.
Let's go by 1.
What?
If you go by
0.1.
dollars,
Oh, 2.
Zach.
What about
0.2.
0.2? Okay. So if we went by 20 cents,
Guys.
this would be $1. So every 5 would be $1. Let's see how that looks. That's nice. That's spread out
Why are
nicely.
you guys laughing at me when I said 0.2? I don't understand.
You never
I
said
said-
point.
Oh, I meant to say 0.2.
Okay.
Yeah.
Alright.
I did. Alright.
Okay, so now that we all have a uniform scale, all of our scales match, I want you to think about the scenario and see if you can create a graph that represents this scenario. Then we're going to check it together, and then together we're going to determine an equation for this graph.
Should we round
If it's open, does that mean it's contained?
If it's open, that point is not contained.
So it will move farther in that direction.
I have no idea. I feel like you got line graph.
It's like one of those dumbbell looking graphs.
It does look like dumbbells.
Alright, well, okay.
I'm not doing anything for this.
It'll be the same as the last one.
Is it from like 0 to 1?
Yeah, that's fine.
Like, one starts to one back into? Yes, thank you. Did you mark the four stars open, right?
$4? I did not. I only need to go to 326, so.
You can. You gotta do that.
I feel like if there's anyone else sitting behind me, they're gonna get this.
Have
I think you're
a package that has no weight.
So what is the
See, that's a close.
The uncircle means it does not include that point.
Okay.
Wait, this is like a barbell.
Yeah.
Oh my god.
Yeah.
I don't even.
Well, I can't really like.
Shut up.
You just like connect them.
I literally cannot make
Is it possible to make the like barbells like at a slant, or do they have to be straight across?
These barbells are straight across. It is possible, but not in this situation.
How can we make this
Circle's tiny, like.
Yeah, you'd have to make the circles kind of tiny. You're correct.
Scale factor on this graph is too low.
Huh? Just get some. Are you in the arms?
Do you just like do a line and then make it to the next?
Not an easy graph to
This, or
graph.
just do like a line and an open circle, and then like go that point like that. Like I don't probably.
It starts with an open. I know it starts with an open. I told you.
I think a lot of, from what I'm listening and what I saw when I was walking around, a lot of you have a really good idea. And then most of us have connected the dots, and then some of us just need a little bit of help. Now, the first thing we have is the point right here. Let me change that to pink. Because if we have nothing to mail, it won't cost us anything. So if it's weightless, we have nothing. So we have this little point right here, and if you didn't draw in that point, that's fine. Because it doesn't really apply to mailing something. I wouldn't go in to mail nothing. Now, if it weighed anything up to an ounce, it's $1.22. So, as long as it weighs more than 0, up to an ounce, it's $1.22. So we have an open circle right here at 0, and a closed circle right here at 1, and everything in between cost us $1.22. Okay? And then we increase by 17 cents when we go up to 2 ounces. So, actually, yeah, up to 2 ounces. So increase by 17 cents, that puts us at $1.39. So if it were 1, it wouldn't cost $1.39, it would be down here, but up to 2 costs $1.39. And then as soon as we're over 2.001, now we're paying for 3 ounces, and we're up to $1.56. So I'm guesstimating. I'll say $1.56 is really close to $1.60. Okay, so we go up another 17 for 4 ounces. Now we're at $1.73. And then we're up to $1.90 for 5 ounces. So that's getting us close to that 2 range. That closed circle wasn't quite in the right place. There we go. And then we're up to $2.07 for 6 ounces. So it's going to look like about that. And then we're up to $2.24 for 7 ounces. I feel like one of these is a little bit off. Maybe it's that one.
It's alright.
I'll throw it down a little further. There we go. Because it looks like I'm increasing by 17 cents each time. Okay. So now I'm up to 241. So just past. And I did that one probably a little far. There we go.
This is so like it's hurting my eyes.
And then we're up to 258. So we're just about to the next one. And then we're up to 275. So that would be pretty close to the next one. And then we're up to 292. So that would be really close to $3. And then we're at 309. So just over 3. And then we're at 326. So a little bit over here. Okay, so our jump every time was 17 cents, wasn't it? So that's the same as our vertical stretch, isn't it?
Yeah.
Okay, so if we're writing the equation, we know that we need 0.17 out in front here, because that's what we jumped by. But we got a problem. We studied rounding down functions yesterday, and our barbell looked like this.
Yeah.
This is rounding up, and our barbell looks like this. So we know we have a rounding up situation here.
So the other one's running down.
Okay.
I see it.
I give up on that.
Okay, but if I plugged in 1 right here, that would just be 17 cents.
So it's plus.
And 1 is supposed to be $1.22. So what do I need to add to this to get this 17 cents to $1.22? 1.05.
Where are you
Oh, that makes sense.
Because if I plug in 1, I get 17 plus $1.05 is $1.22. Now, this only works. We'd have to restrict our domain, wouldn't we? For x values that are greater than 0.
So how would you show that?
You would just have to say your domain is for x values greater than 0.
Okay.
So we could
So
say,
instead of
yeah.
negative-
Actually, this only goes from 0 to 13. So our domain truly would be from 0 to 13. All right? You guys over there missed that. I hope I don't put that on next Friday's quiz.
No, you were talking about the greater than. That was like a greater than sign.
Okay? So this would be our acceptable domain for this situation. So let's see if this works. We go to the post office, we give them a letter. It weighs 1.8 ounces. Well, if I plug in 1.8, that rounds up to 2. And 2 times 17 is 34. And 34 cents plus $1.05 is...
Oh wow.
Okay? It works.
That's wicked.
Alright. So, this is a situation that does give us a step function, but it's not rounding down. This is rounding up. Now, if I give you a situation
it can be rounding down or rounding up. But because it gets a little confusing when we're graphing, when we graph, we're going to stay in terms of rounding down. Okay? So if I give you a conceptual application situation like this one, it could be rounding up or rounding down. You have to read
So
carefully.
the graphs are ready.
But your graphs today are again practiced with rounding
So same
down.
as this up here?
I thought we just rounded up.
Oh my god.
We did.
You did, what do you guys do?
Pretty sure you
All right.
Y'all do this one like you're rounding.